Okay, so the next one I'm going to do is reading uncertainty. And reading uncertainty can be split into two types. Reading uncertainty is basically how accurately have you read the meter? Have you read the timer or the multimeter or the oscilloscope or any of these things? How accurately have you read it? How accurate is your eyesight in picking up which digit it should be? So we have two types of reading uncertainty. We have from a digital meter and we also have from an analog meter. Okay? Now, it's a very simple rule for both, but they're different types of rules. So we need to know, right, I'm looking at this digital meter, I'm getting a reading of, say, 0.51. How certain am I? What is my uncertainty in that reading? How certain am I that that's exactly what it is? Okay? So let's look at the digital meter first. Reading uncertainty, digital, right? From a digital meter. So let's look at that one first. And this is going in from a digital meter. Now, what I'm going to introduce to you here is a new symbol, and that symbol will be plus or minus. Okay? So maybe I'll put that next to this just now. You can put it wherever you like. But we're saying the symbol plus or minus like that, this symbol here, this means plus or minus. In other words, if something is 0.5 plus or minus 0.1, then that would mean that the reading could be anywhere between 0.4 and 0.6. It's plus or minus 0.1. So we could go below that by 0.1 or above it by 0.1. That's what plus or minus means. Now, this is actually given in what's called, I'm giving this in absolute form just now. And I'll explain the difference between absolute and percentage later on. But this value can be between, if it's 0.5 plus or minus 0.1, that could be either 0.4 all the way to 0.6, any value in between that. Okay? Right, so when we talk about digital and analog meters, I'm going to talk about things in terms of plus or minus. So, in terms of a digital meter, the uncertainty or the reading error for a digital meter is plus or minus 1 of the smallest of the last digit. Plus or minus 1 of the last digit. Okay? So, so we're looking for, so the uncertainty in a digital meter will be plus or minus 1 of the smallest unit. For example, if we have a multimeter and it gives you in 0.002, then, and that's a digital multimeter giving you that, so it's in a multimeter like this, and you're reading it off the screen like that, then the answer will be 0.002 plus or minus 0.001. So the reading can be anywhere from 0.001 to 0.003. So that's your uncertainty here. This here is your uncertainty. 0.002 plus or minus 0.001. That is plus or minus 1 of the smallest division. That's plus or minus 1 of the smallest unit. So let's do another one. Let's say it's 2.654. And again, that's inside a meter somehow. That's inside a multimeter. Then our uncertainty would be 2.654 plus or minus 0.001 again. Because that's your uncertainty. That's plus or minus 1 of the smallest unit. That'll be our digital uncertainty, our digital reading uncertainty. Okay? So if you're reading a multimeter at all, that's how we do it. Now we will do an LO3 experiment where you'll have to identify your reading uncertainty, and possibly it could be an analog or digital scale you're looking at. Okay. Now right now we're quoting these in what's called absolute values, and I'll explain the difference between absolute and percentage once we've gone through the different types of uncertainty. Right, second we've got reading uncertainty analog. Now this is from an analog meter. An analog meter is anything that you've got a needle going through a scale. So generally analog meters tend to be like a scale with a pointer on it, and then you've got a scale that goes along like this. It's quite I've seen this question come up in exams a couple of times where they actually say, right, what is the reading uncertainty from this scale? And this scale might have units on it that you can be familiar with. Let's say it's got, like, say 1, 2, 3, 4, 5, whatever. It could be volts, could be amps, could be whatever. And the reading uncertainty now is, so the analog reading uncertainty is plus or minus 1, oh sorry, no, that's not right, plus or minus half of the smallest division. So using this as an example, I've got 1, 2, 3, 4, 5. Now what is the smallest division I can see on my analog scale on this one here? It's the smallest one I can read off this scale. Robert, can you read that? What's the smallest division I've got on this scale here? Pardon?
10.
So see, between 2 and 3 is 10 lines. Just one. So what does each line stand for then? 0.5. Yeah, good. So that is 1, another 0.5 layer, 0.5 layer, 0.5 layer, 0.5 layer, that's all a 0.5 between them all. If there was even more lines in between, then that would be the smallest division. The smallest division is the smallest separation you've got on your meter here. So for this one here, the smallest division, is 0.5, which means that this reading here would be 2.5-ish. So the reading is 2.5, but the uncertainty is going to be half the smallest division, which means it's going to be plus or minus 0.25. Because that's half the smallest division. The smallest division is 0.5, and that's half of it, it's 0.25. So my reading could be anywhere between 2.25 and 2.75. That could be my uncertainty. Any questions on that?
So what's the uncertainty again?
What's the what? That's uncertainty there, 2.5 plus or minus 0.25.
But then you say something else.
I says your reading could be anywhere between 2.25 and 2.75. But that's what that means. Plus or minus 0.25 means it can be anywhere between 2.25 and 2.75. Okay. That's how you calculate the reading uncertainty for digital and analog. Last thing we've got, random uncertainty. This is the easiest one.